sees as the most interesting opportunity for virtual product development into the future? What's the real golden future for this capability?
So the question goes to all of us, yeah. So.
Or whomever would like to answer, if anyone has a good answer that they want to throw out.
Probably let me start and try to comment and try to answer. Yeah. Well, generally it's all about, or maybe not all, but a large portion of it is about facilitating a front loading of development activities by providing advanced simulation tools and methods. So to shift development activities from the road and the test rig towards the office, and so that's and to streamline the processes in the office. So that actually means, so what when we talk about, let's say, virtualization of development, and then virtual development of control algorithms, that's a major important aspect there too, and virtual testing as a keyword, and so that means we need reliable plant models, so fast models, real-time capable models with a high, let's say, predictive capability to really, the models really to have the real behavior of the component or the subsystem reflecting properly, and ideally these fast-running plant models automatically come out from the preceding development process. So when already when setting up models in the early concept phase to derive the requirements, it's good to have these models reused in later phases of the development process to populate them with information as it is emerging out of the development process. So once you have 3D simulation results, to use these results to parameterize and optimize your fast-running simulation models by still and by still maintaining their fast running, or can be later on, let's say, reduced again for being fully real-time capable on hardware-in-the-loop platforms, by still maintaining the predictive accuracy, and so without the need to, let's say, set up models from scratch again for hardware-in-the-loop, let's say, engineering tasks.
Yeah, well, in the context of what Reinhard was mentioning, I agree that this kind of real-time solutions based on the management of the formal knowledge can be a game changer. And then a smart combination of working in this way, where maybe you could be simplifying a bit the problem, can be combined with in key milestones with more high fidelity assessments, as we are doing now. But it's obvious that prototypes are being reduced. Some companies are going directly to the production models directly without prototypes, and all these tools will be needed, combining combining better communications, high HPC facilities, and a smart strategy to do some work upfront, and then use this to define some parameterized models in order to get these real-time simulations.
From my point of view, in order to give another kind of response to the question, it shows that industry has a lot of need in terms of increasing the simulation part because of many problems. We work with some company, and of course they are increasing simulation, increasing hardware group testing, and so on. All the project work on new methodology. So the problem is what is the confidence within this new methodology? We should demonstrate that it works and it is easy to get. Another problem is the training. There are some questions before for all the presentation, how time it takes to learn about IA and or EMR and so on. It shows that if we switch to other methods, we have also to develop training methods in order that engineer can easily be trained on that to switch. And training is not a simple issue too. And another aspect, and it is also some question relative to industry property, how to be sure that each partner can keep his IP. And it's not also a trivial issue. That means that we have to work technically, of course, in order to propose an advanced technical solution, but we have also to work on what is around teaching, IP, and so on.
Okay, so I want to again say to the audience that you can throw out your questions, although I could probably ask questions all day. And I guess I'll ask a second question, which is about how the rise of virtual product development might change the roles and relationships within the automotive industry. And that is, historically, OEM manufacturers to some degree have been in charge of systems integration for a vehicle and played a dominant role in the industry. If a lot of these new tools facilitate systems integration, does it reduce the importance of the OEM manufacturers because the component manufacturers are more critical? Does it shift the relationships in the industry, or how might this change the face and relationships in the automotive industry?
Well, maybe I may comment on that. I think the increasing virtualization will bring up new modes of cooperation or co-working. So we're actually going in the direction of having a virtual co-working space in the cloud or in what mode ever, where the supply industry that already has got responsible for fully responsible for component and subsystem development, that they already in the early concept definition phase and in the development phase more intensively interact with the OEM, but also interact within the supply industry by co-working on let's say on digital twins. Let me say and jointly optimizing them, and that is expected to bring further efficiency gain in the whole development process.
To me, the tendency to, as I was mentioning before, to reduce the prototypes, to avoid the prototypes, and to virtualize everything, it's very, very, very clear. However, I have the feeling that the virtual tools have not really changed to do so. So there is still a strong pressure and a big risk by doing so. Yeah, maybe as a CAE engineer, I shouldn't say that, but I'm working in this since 25 years. But when we work only by simulation, there is always still the concern when you will finally test the real case. And this means that the pressure goes completely to the simulation team. And also, in addition to this, my feeling in the industry is that this is requested, but also the resources for simulation in the industry have not been really growing. And if we check, for instance, the budget of vehicle development, simulation is not really the big piece of this, and still design, still prototyping, testing, etc. is the big part of the pie. So I think we are not in a very comfortable position. That's my opinion.
On that topic, I would like to add a comment about the comment of Reinhard, because co-working is increasing more and more, and it's important to be prepared to that. And moreover, it's the time of open access. Every agency and so on has to pressure us from industry, from academy, to have open access philosophy. I believe it's important. And from the European Commission, why it is important to have such open access in the automotive industry that is globally conservative is that the European Commission believes that what is the dynamics in the economy is the SME, because of the size of the group. There are a lot of innovation and patents that are not today used because the company is not so strong. And if we can have some methods that can integrate easily this small company and dynamic company, it could be a way to increase the dynamics of development. So a new company can develop a new battery, but it's not so strong to demonstrate. If there are some tools that enable this company to show to OEM and so on that his product can be of interest, it's a way to speed up also the innovation. And of course, as said by Valentin, today we are in the crisis that demonstrates that we need to increase teleworking. How to do that in an efficient way? And we need new tools.
I would like also to add that exactly as it was mentioned by Ellen, this concept of open access, but maybe in more wide sense, open research, open science, will play maybe more and more important role in the future. Because the main innovations, as we can observe now in an automotive industry, to be honest, are coming not from established OEM companies anymore, but from a new commerce. It is mainly small to medium-sized enterprises or small business, and exactly as you know, several years ago, Tesla made all patents open. And it was not obstacle for the Tesla to have now a highest position on automotive market. And I believe in future, this will be a good example also for other companies.
Okay. So I have a question here from Abdullah Pam of the University of Lille, sort of a general question about your impressions well, I'll just read the question. If BEVs keep improving in terms of efficiency and range, how does this impact the potential evolution of fuel cell vehicles? You know, which I think is sort of the billion-dollar question of the automotive industry, maybe.
Well, that's a very good question, yeah, and because there is already something going on in the market in this context, and it's somehow, for as my impression, it's already becoming a bit visible that the development activities in the fuel cell area are strongly focusing now on commercial vehicles, on long distance transport, and so it seems that there benefit there will be is more clear benefit both on the environmental side and also on the commercial side. So it's obviously visible to shift from conventional IC engine to fuel cell, and under the constraint that in long distance, in long freight transport, the battery weight and the battery volume is prohibitive and would actually reduce the payload, and so that's from the technical side. And also regarding the hydrogen infrastructure, there are studies that with a relatively small number of hydrogen fuel stations along the major trans-European highway routes, you could have a majority of the long-distance freight transport converted to hydrogen. So and that again, once that's going to happen, that again will then, how to say, bring up then reprioritize then the passenger car fuel cell topic, especially on the larger vehicles, on the more heavy vehicles, luxury vehicles, SUVs. There is still a lot of room for fuel cell technology in future.
It shows that if you look the European roadmap on transportation system, so BEV is more for light vehicles, and fuel cell vehicles will be more focused on buses, trucks, and so on, as said by Rainer. So the tendency is globally is this one. But before going to a mass market of electric vehicle, maybe there is some place for also passenger car FC vehicle for long distance, as there are some companies that sold this kind of vehicle today. But infrastructure will be also a key challenge to do that.
I would like to add at the end, okay, maybe with new technologies in next decade, fuel cell vehicles will be real competitors for electric vehicles. But independently, in my opinion, all the solutions which were presented today in or for European projects are also applicable to designing new fuel cell vehicle systems as well.
Excellent. Okay, we seem to have lost Enric, but I guess we're approaching the 3-hour mark, and so I would propose that we end this excellent session. It was 4 great presentations and a good discussion. great audience, lots of questions. So I'd like to thank all of our presenters. I'd like to thank the audience for sticking around. And I hope that everyone had learned something and had a good time at the same time.
Okay.
Thanks.
A pleasure to do this workshop together. And finally, we have more than 80 attendees. Most of them follow the workshop all the time. So it's a success on that. And it demonstrates also that we have a internet connection that can be used for meeting, but maybe for testing too.
Okay. Well, thank you, everyone, and goodbye.
Bye-bye. Bye-bye.
Bye-bye.
Bye-bye.